Hi everyone. So you've done a little bit of revision now on your previous electricity topics, electricity 1 and 2. We're going to start electricity 3. Electricity 3 just builds on everything that you've done in electricity 1 and 2, and it introduces you to a few new equations and a few new circuit diagrams. Okay, so what is in this? We know ohms already. We know vehicles IR. So we're looking at some special cases of vehicles IR, and we're looking at potential divider equations, which helps us identify voltages in certain circuits, which is a little bit quicker than using vehicles IR sometimes. So that first box there is all about potential dividers. And then we also look at a bit of practical electronic circuits and how they work. Okay, so there's not a lot in this. There's quite a bit of practical aspects that hopefully I'll be able to send you videos of as well. So we're going to start just by looking at electronic systems. So electronic systems. So when electronic components are joined together, they form an electronic system. So electronic systems, they all work together to do whatever they are designed to do. So they use to process signals or information. The electrical signals are usually voltages and then usually divided into three main parts. And they are the input, process, and the output. Okay, so you get something put into the system, it gets processed, and then it comes out in a different format. So for example, a parcel counter. So in this one, what we have parcels moving along a conveyor belt, and they will at some point cut this light source. It's basically a light gate, okay? And whenever something cuts that light source, the signal gets sent to the counter, which tells you how many parcels there are on this conveyor belt. So the input is the light sensor, the photocell here. Okay, so when it stops sensing the light source, it means there's a parcel going past it. The process is the counter, so it counts up how many times that happens. And the output is the display, so in this case, a liquid crystal display, LCD, a liquid crystal display. So like a monitor or something like that, that just shows us what the number is. So input is the light or the light sensor. The process is counting how many times that's interrupted, and the output is just what we can see and we can read. So another couple of examples here. So we've got a public address system, so a PA system, which is basically you speak into a microphone and you hear it 10 times louder, so you can address people at the back of a room. Okay. So for this one, the input would be your microphone because you're speaking into it. So microphone, I'm just going to shorten it to mic for just ease of me writing. The process is the amplifier, so the thing that makes it louder. And the output is, of course, the loudspeaker. Example 3 actually is a little bit of an old-fashioned example because I think some of it is just thinking of it in old-fashioned ways. So there are lots of different ways that input into a personal computer, PC. There's only one thing that processes, which I can tell you now, is the CPU, the central processing unit. And then there are lots of different ways to output as well. I will actually add in another box here because there's another input that didn't really exist when this booklet was written. So pause the video just now and have a go at thinking about what is input, what do I use to put input signals, and what do I see coming out of it. So pause the video and then I'll go through the answers. Okay, so inputs. So we've got the words here. So what do we use to input signals? We can use a mouse to input because we use a mouse to move around and click what we need to click. What else? We could use a monitor if it's a touchscreen monitor to input something, and that's the thing that wasn't expected when this booklet was written. We could also input using a keyboard because we can type things in. A modem sends and receives signals to the internet. So a modem is input and an output. Let's put that in as well here. And a monitor obviously is also an output because you see things coming out on the screen. Okay, what else? We've got a printer. Printer is an output, definitely. You don't really put things in. A scanner you would put things into, but a printer prints out. So printer. And I said a scanner, you scan things in, don't you? So scanner. And one more thing, which could be both, memory stick. So obviously you can save things onto a memory stick, but you can also put things onto a computer from the memory stick. So memory stick for both. Okay. Right, so some things can be both inputs and outputs, but generally you only really have one process. Another part of the basics of our electricity 3 or our electronics is analog and digital signals. Now, to tell the difference between analog and digital signals is digital can only be one or the other value. So one value or another value. Can't be anything in between. Okay, so there can't be any slopes in a graph. It has to be just flat line or another flat line. Okay, so signals used by electronic systems are of two types, analog and digital. Analog signals can vary continuously over a range of values, but digital signals can only have one of two distinct values, so high, low, 1, 0, on or off. Okay, so we're going to look at the following waveforms and decide whether the signal is analog or digital. So I'm just going to put A for analog and D for digital. So the first one is definitely digital because you can see it's either that value or that value. There's nothing in between. It goes straight up to the other one. The one to the right of that is analog because it's all over the place. It could be any value there. I'm going to go down. So I'm going to go down here. Again, that value or that value, nothing in between. So that's digital. The last one, quite often people get wrong because they think, oh, it's just this value or that value, but it's not because there are bits in between here. Okay, so we've got a value there and a value there. Okay, so that one is analog. That's tricky, that one. So, for example, a mercury in glass thermometer is an analog device. Since the mercury can take up any length in the glass tube depending on the surrounding temperature. But an electronic thermometer is digital because it might only read 1 degree, 2 degrees, 3 degrees, or 0.1 degrees. It doesn't go to like 0.1, 5, 3, 2, 6, 7, 8, it just only goes to certain steps. So it's digital. Okay, and last but not least, I want to go through this page. So I'm going to give you a video. Hopefully I will provide you with a video of some of these, if not all of them. And I want you to think about the energy changes involved in them. You should know the energy changes of quite a few of them. And have a think about whether it's analog or digital. Now, this one could be one or the other, or it could be both. Okay, so don't worry if you're not really sure. And the circuit symbol we will go through at the end, but if you know any of the circuit symbols, pop them in as well. Okay, so for example, we'll do the first one together. Microphone. We know this one, we should know this one, is sound to electrical. So that should be an arrow in between. Microphone is definitely analog because it picks up lots of different sounds. And the circuit symbol for a microphone, you might not know this one. Looks like that. So a thermocouple is something that changes heat energy into electrical energy. And solar cell you should know. The rest of them you probably are aware of. The one that you might not know is relay, which a relay, we have talked about relays before. A relay uses electrical signals to produce movement, and solenoid is also the same kind of thing. It uses electrical signals to produce movement. Okay, so I'm going to stop this video just now. I'm going to get you to watch a video of all the different pieces of equipment, and I'm going to go through the answers afterwards.